They are a little low. Maybe this is like the New York Giants or New York Jets. I don't know.
Did New York do to you?
What was that? Sorry. Yeah, that's terrible. They're run by a bunch of people with no idea what they're doing. All right. So let's look at game one. Guys, quiet, please. So this, don't write down. I'm going to show you what I want you to write down in just a moment. But let's look at game one, just to kind of just take a moment to observe what's happening. In game one, let's say a team scores 5 touchdowns. How many points would that be? Be 30. For those who follow football, if you don't, it's okay. A touchdown's worth 6 points. An extra point, exactly as it means, is worth how many points? So 4 points total. And then it made a field goal. It was 3 points. So how many points did they score? 37 points, okay? But here's the problem. For me to do this, I mean, it's not that hard. Actually, the math was pretty simple. But to do this 3 more times may not be efficient. If you think about like for a full season, a team plays 17 games, right? To actually do that 17 times becomes very cumbersome. So what I would suggest that we do is we make a matrix of all the types of scores they get. Guys, quiet, please. Make another matrix of the point values for each of those items, and then multiply it out. So this is what I do want you to write.
Solving for them.
The total points they score for all 4 games.
You
Well-
just said you could, but it'd be inconvenient.
Yeah, so what we're gonna do is instead we're doing number 8, to be honest, because number 7 would be to do that individually. Like I know that's 37. Actually, what the heck? Let's just do it right now. Okay, how many points was the first game? Okay, so you were saying let's do it mentally. Fine, let's do it mentally. So I actually do write this down. We'll do the matrix multiplication number 8. So game 1's 37 points. How about game 2? If you do mental math, 12, 14, 23 points. Yeah, because that's 12, 2, and 9 points. So that's 23 points. Very good. How about game 3? They didn't do very well. 12 points. Yeah, we went to NorCal championships. And then Nathan missed all his field goals in game 4. So, and he missed an extra point. So 18 to 20 points. There we go. Okay. So altogether, they scored, it looks like 92 points. If you were to add it all up. Now, another way you could do this. John, I really need you to focus, dude. Thanks. No, just ignore him. I don't know. All right. Or if you need to go take a walk to settle down, that's fine too. All right. Okay. Here's what we're gonna do. Let's go ahead and line them up like this. Game 1, game 2, game 3, game 4. Okay. And we're gonna do touchdowns, extra points, and field goals. So if I look back at what we have here, wasn't it 5-4-1 for the first game?
5-4-1.
So what I'm doing is I'm stating the number of each type of scores for each game. So 5 touchdowns, 4 extra points, 1 field goal, 2 touchdowns, 2 extra points, 3 field goals. Then we do 1-0-2 and 3-2-0. All right. Now we're gonna make a second matrix, a 3-by-1. This is a 3-by-3. This is a 3-by-1.
You feel like game 1, game 2.
No, now I'm gonna do the point values for each of those items. So for the touchdown, that was worth how much? 6 points. 6 points. You still got to kick a field goal or do a 2-point conversion. Extra point was 1 point.
1.
And a field goal.
3.
Okay, now this is the part I really have to emphasize. The order matters big time. Touchdown, extra point, field goals. Touchdown, extra point, field goals. Now, did I have to put touchdowns the first time? No. If I put extra points here, fine. Then I better put extra points in the first item here. That was your question?
No.
Okay. But those of these match up. 5 goes with 6. 4 goes with 1. 1 goes with 3. Look at the next game. 2 goes with 6. 2 goes with 1. 3 goes with 3. 1 goes with 6. 0 goes with 1. 2 goes with 3. Fine. 3 goes with 6. 2 goes with 1. 0 goes with 3. It's close. Close to it. So here's what we're gonna do next. We're gonna let the calculator do its magic again, but then I'm gonna show you how to do this by hand, and we'll do some other problems. Okay? No, not now. We multiply. Yeah. All right, we're not gonna raise to -1, guys. So let me pull up the calculator here. Okay, turn it on. That's when you're trying to solve an equation with unknown variables. We're not doing that for this problem here, but we'll do that on Friday. Fit alpha zoom. We have a 3 by 3, right? Correct. So you have 5, 4, 1. And after I finish this problem, I'll show you exactly the mechanism of what's happening. 2, 2, 3. I know you're right. It's a 4 by 3. Shoot. It's okay. I got distracted by John. I'm just playing for everything today, that's all. Just kidding. No, let's keep going. Okay, 4 by 3. My apologies. There we go. I should pay attention. That was my fault. Okay, so 5, 4, 1. 2, 2, 3. And it's a little a bit of pain. 3, 2, 0. Okay, then we're gonna multiply it to a 3 by 1. Hit alpha zoom again. Switch that up to a 3 by 1. Yeah, we're just multiplying. Because what you're doing is you're because you're taking each of these items here and multiplying to the point value that one. Oh, you don't have to do that. You just type the next matrix. You don't need to. So 6, 1, and 3. Okay, so we get that, right? You get 37. Hold on, let me write it out. Okay, John, seriously, I'm gonna have to ask you to leave back one more time. It's been like 10 times. I'm being super cool, super patient. But no, seriously, John, I will. Thank you. All right. You've been warned. Thank you. I appreciate it. And I'll still have you come back, but you might need to take a little break. Okay. Okay. All right. If you say so. All right. 37, 23, 12, and 20. Now, what is happening? Here's what's happening. These have to line up. Okay. The inner dimensions have to line up for the multiplication to happen. The reason why is because I need a 5 to match the 6. I need a 4 to match the 1. I need a 1 to match the 3. If these don't line up, we can't do the multiplication. What's the final answer? Whatever you see here, 4, 1. How many rows do I have?
How does it like know to like line up with each other?
It's because we set it up that way.
Wait,
We were intentional setting it up that way. Let me show you the process. Here's what's happening. And it's gonna make more sense once I do another problem. Okay. So what you're doing is you're lining up this row with this column. You're actually doing this. You're doing 5 times 6 plus 4 times 1 plus 1 times 3. If you work all that out, what does that become? 30 plus 4 plus 3. The calculator has an algorithm that does it. So you get 37. What if I multiply the next row?
6.
Okay.
3 and 1. Does it change it?
Okay, so if you did that, that's a great
Then would you have to
observation.
switch the field goal to be the second one in the row?
No, here's what's gonna happen. Let's do it right now. If I were to repeat that, so you're saying switch the 1 and 3, right? Okay, what you're doing is now you're telling an extra point is worth 3 points,
So that,
and
I'm saying if you
and the field was worth 1 point.
if you put the field second and then the extra point last, we get to put the field
So
goal
then-
second in there.
So now I would have to swap these two afterwards.
And then I would work.
It would still work, correct? You could do that. That's a possibility. If you want to do it, if you wanted to have touchdowns, field goals, extra points, but you have to make sure you do the same thing the other matrix. But if I did that, things change now. Because now you're saying an extra point, which we know is not true for those who follow football. Next point's not worth 3 points. It's so close to the goalpost, right? But now let's actually go through some more examples, and then we're actually going to do another problem, and I'll show you how this process works. Okay, so number 9. In order to multiply these two, you need the inner dimensions to match up. So this right here is huge. The product, guys, quiet please, is going to be the columns. Sorry, in order to multiply it, the columns of A has to equal the rows of B. And the order matters. Order matters. You can't mix up the order. Like 3 times 4 is 4 times 3. Not true for matrix multiplication. So you need these numbers to match up. And the final answer is going to be the outer dimensions. So this is the key point here. In order to, this is why I want you guys to write it down. In order to multiply two matrices, the inner dimensions must equal each other. And the product will be the outer dimensions. Okay, very, very important. So looking at this scenario, I don't have matrices, I just have the rows and columns. So that's 4 rows and 3 columns. How about B? How many rows does that have?
3,
You always would say rows first.
2.
And 3 columns. Okay. So do these line up?
No.
Those don't line up. So in this case, this is not defined.
But there's more than.
So AB can't be done. However, do these line up?
Yep.
Yes. Because that's going to be 3 rows. Sorry for messy handwriting. And 4 columns. I'll abbreviate. That's 4 rows and 2 columns.
Okay.
So what's the final answer going to be? What's the final answer? 3 by 2. Think out, Elia. So I'll be 3 by 2 when I work it out. So let's, and if I were to show you really quickly how that would look, I'm not going to write out. Actually, let me just really, you don't have to write this down. So I did 3 rows and 4 columns. I'm putting a bunch of 1s just for simplicity's sake. If I do a 4 by 2, so 4 rows and 2 columns. You guys see how things line up. That first row lines up with that first column.
And what is the second column doing?
Nothing for now. But do you see how each number here pairs up with each number here?
Yeah.
That has to happen for the multiplication.
Oh, because the other one was 4, and then there was only 3 of them.
Correct.
2.
Correct. Right.
Hmm.
So you need to have the inner dimensions match up for this to happen.
How can we check that? If we just have, we just have to know.
I'm going to show you in a moment. So I'm going to do a more concrete example in just a moment. But questions on that, the inner dimensions have to line up, and the final answer will use the outer dimensions. Okay. So M by P with outer dimensions, the ends have to line up. So you need these have to be the same. Final answer is M by P. All right. So let me skip down to let me skip down number 11, and we'll go back and do the hockey example number 10. So let's look at number 11 really fast. Here's how I want you doing this. I'm going to write the matrices again. So this is 1, 4, 3, -2. Okay, and this is what I've done when I've taught this to Algebra 2. We did actually have this concept, I think, 5 or 6 years ago. And then we put in pre-calcs, we brought back to Algebra 2. Here's what I want you doing. This, I think, hopefully, will help make sense of this process. Okay, it's going to sound very robotic and mechanical, but just go with it. Well, thank you. I think you probably see what I'm doing.
Saying row 1, column 1.
Okay. Again, you gotta be highly methodical about this. Okay.
Methodical.
The left matrix I call the row matrix. The right matrix I call the column matrix. You're taking the rows here, so it calls row 1, row 2. The right matrix is called C1, C2. You take R1 and C1, put it here. Take R1 and C2, put it here. Take R2 and C1, put it there. And put R2 and C2, put it right there. Okay.
No.
Is there ever a time where there's like 3 or 4 matrices?
We might have
Not that
to
we're doing, but like.
multiplying 3 or 4. Yeah, it's a little much, though. I wouldn't do that to you guys.
So like, do people use that?
Well, of course, yeah, combine, yes, but you use the computer program to do that. Yeah, I'll do that in a moment. Okay, so here's what we're gonna do, guys. Here's how it looks. When you combine R1, let me get a highlighter here. If I combine R1 with C1, here's how they line up. 1 times 5 plus, and I'm going to kind of just sit on this for a little bit because I do not want to rush this. This can get confusing. But if you see the order of things, it's pretty easy. What does a 1 line up with? What does a 4 line up?
9.
So we have to take the products and add the products. What's a product of 1 and 5?
Okay.
What?
Product.
Oh, 5,
5. What's a product of 4 and 9?
56.
And then when you add those two numbers together, you get 41.
Hey.
Good. Yes, you get 41.
You multiply them.
No, because you mix a product with some. Don't worry about it. It's all good. Okay, so Nathan, here's what I did. I took the first row of the left matrix. I took the first row of the right matrix. I lined up corresponding numbers. So one corresponds, one's the first number here, 5, 4, second, 9, 7. I have multiplied those pairs and added to pairs. You guys are adding multiplied pairs. That's what we're doing. We're adding multiplied pairs.
Like, I don't get like, it's actually.
Yeah, and why are we?
Why not?
You will see once. Be patient. You will see in a moment. Just be patient, because it's going to explain the stuff we've been doing to calculate the inverse matrix. It'll explain why it works. Yeah. Yes.
What?
Yes, you have to do this. Yes. All right. Next up, I know you guys asked a great question. What is the big picture here? Just be patient. No, that was Lincoln Lowe's question, John. Yes, good. Yes. No, I'm gonna put fractions for your test only, Aiden. I'm gonna write you a harder test. Yes, they'll be nice numbers. Don't worry. I know there's a little snide in me. Sorry. Okay. Next up. 1 times -7. Good. Plus 4 times 6. Awesome. What's that going to come out to being? -7 plus 24. Very good. Good. Okay. Let's keep moving. And you guys can see what I'm trying to do. I'm trying to get all these pairs and add up the multiplied pairs. So next up, I'm doing R2 C1. And again, this is recording, so you have this as a reference if you need to watch it again. So it's all beneficial for you. Go ahead, Samora. What are you going to say? Awesome. Good. So that's 15 and -18. That's -3. And then one more time with R2 C2. Sounds like a Star Wars character. R2D2, I know, right? So let's see here. So we have 3 times -7. And -2 times 6. Which should be -33, I think. Yeah, so all you're doing right now, it's a very dry, boring example. All you're doing is you're executing a matrix operation. You're learning how to multiply these two matrices. And remember what matrices are, they're just an arrangement of numbers, right?
Wait, so if you plugged in this for like the R1, R2, and C1, C2, exactly, would you end up getting 41, 17, negative?
Correct, you would.
So that we're just doing it without the calculator.
Correct.
But we won't
Yes.
cover like the -1 without the calculator.
No, that's really hard to do. So let me back up a little bit on what we've done. Let me show you my solution key for the previous homework. So Lois and you guys asked a great question. Like, how does this help us? What do we do? How do we use this, right? Okay. Without you realizing it, You've actually been doing matrix multiplication for the last 5, 6 days.
Really?
Yes. So this right here. Wait, let me start one, dude. Like, stop.
Lincoln, bro,
Yeah,
stop putting
right.
writing
Right.
pencils in his hair. There's
Lincoln,
like 30 in there.
Stop. Thanks.
There's like 30 in it.
Okay.
See him.
So this inverse matrix, right? It's actually being multiplied to this matrix. What's the dimensions of this matrix here? Three.
3 by
Oh, this one.
3 by 1.
301. So those match up, right? That's a 3 by 3. That's 3 by 1. What you're actually doing is you're letting the calculator do the multiplication for you. It's actually multiplying these two together. When it multiplies these together, what does it get you? Gets you that. And that's going to be the answer for X, Y, and Z. So that's how it helps you. When you do the matrix multiplication, it actually helps you solve for X, Y, and Z. Now, where does X, Y, and Z go in this whole situation? That would be for Friday. I'll talk about that on Friday. Friday, everything comes full circle. But that skill of multiplying, we're going to have to do it for us, but that's what it's doing here. It's actually multiplying these two together to get you that answer. So the product of these two, of course, raised to negative 1, whatever that means, which we'll talk about on Friday, allows you to get the answer. More good.
Wait, for 11, it still says find BA, wouldn't it just like be the same?
No,
Or
good.
would it be
It won't
different?
be the same. It'll be different. Let's talk about 11. Good. Let's move on to 11. John, go ahead. Yes. Yes, go ahead. Mhm. What are you going to say? Say something good. Something intelligent. Let's just get right to it.
Hold on.
Don't you hate that? I hate that.
Keep going.
I will. All right. Okay, let's reverse it. Let me know when your thought comes back. I'm curious to hear this. So quiet. Here we go. Okay, BA. BA things mixed up now.
Oh,
Yes, go ahead. Yes.
on the test, so
Mhm.
this is this the only like what else is gonna be on it? This times what new
Well, I mean, the stuff that you were here on Monday for, we'll talk about that. That's like solving 3 equations, 3 variables, like with word problems.
Oh,
I'll tell you guys by
What-
Friday. You're on Urban Plunge. It's okay. Here's during homework. We can go over that. So during homework time. All right. What did I just do? I reversed, guys. I reversed the order. All right. The order got reversed. Now here's what happens. You're still going to do R1, R2, C1, C2. But now all this changes.
Why?
Because my first row and first column are different.
wow.
Yes, that's
Wait,
right. So here's what happens.
Oh,
What's my row 1?
5.
And what's my C1? So I'm doing 5 times 1 and -7 times 3. That comes out to being -16, not the previous number, because everything reversed. So matrix multiplication, there's a term called commutative, like 5 times 6 is 6 times 5. We know that. Not the case with matrices. It's a totally different ballgame because of the nature of how we're combining things. 5 times 4, -7 times -2. That's going to be 34, I think.
What number is 11?
Still part of 11, yes. It's just this. No, because I'm doing R1, C2. Or talking about R1, C1 or R1, C2? Right here? Yeah, 5 times 1, -7 times 3. Because I'm doing R1, C1. I know my handwriting's not the greatest. I apologize. 9 times 1, 6 times 3. That's 27. And then finally, 9 times 4 and 6 times -2. 12, which is 22. Totally different numbers now. It's the math is super simple. Both by adding. You have to remember the order, right? But if you organize it as R1, R2, C1, C2, and realize, hey, I'm combining R1, C1, R1, C2. And guys, guess what? Isn't this the first row? Is that the first column?
Yep.
Is that the first row, second column?
Yep.
Yeah.
Second row, first column, second row, second column. Okay.
Row one.
Right. So I'm putting in those places where they belong. So we're good. Hmm?
Be like rows or things.
I've not written the test. I don't know yet. But let's try it. Could I not? I don't know. It depends.
Can you do anything more than like 2x2s or whatever?
He just asked that. She just asked that. We might. I don't know. Let's look at number 12. And I want to go back to the word problem number 10, and then we'll be done for today. All right. And we get out. Yeah, we got plenty of time for homework problems. What time? 11:35. Okay, we could squeeze all this in. But I don't think I have time for homework. But anyway. Okay, how would I go about 12? Just write it out.
I try.
Well, let me write this out first. And why don't you do this B plus C? So this is what you missed. Actually, you saw the word problems. You missed the matrix addition. So let's talk about the addition. Okay. So B plus C is going right here. All right. So yes, John, go do it. What's B plus C?
B.
B plus C.
Oh. Huh?
B plus C. Well, what do you think? I'm adding B to C. So what's -3 plus 1?
A2.
Good. What's 0 plus 4?
Huh?
Okay. Do you see what we're doing?
John.
What's 1 plus -3?
-2.
And -2 plus -1?
-3.
Okay, good. That's the first step. Now, can this multiplication happen? Do the inner dimensions match up?
Yeah.
They do. So now, what's your final answer going to be? Good. Good. You guys are getting it. Good. Awesome.
What's the if they can multiply or not?
The inner dimensions must match up. Excuse me, the inner dimensions must match up. So these have to match up.
Just this.
So the columns of the left matrix has to equal the rows of the right matrix.
I thought it was the other way around. I thought the rows had to match the columns.
No, the final answer, no,
Did you say the first ones are?
what I meant was each of these rows have to line up with each.
Oh, yeah.
columns.
But
That's what
that one's are rows and those are columns.
Correct.
Got you from the bag. So just. And I'm in today. Come on.
Well, let's see how you do in practice. I don't know.
You do on the test, John. Monster.
Yeah, you tell Nathan. All right. All right. So I'm gonna save some time here. Wait, what? I missed that. What's going on? I Okay, guys, we got about 12 minutes left. Let me finish the notes. Guys, quiet, please. Thank you. All right. Okay. Guys, please, let me finish. You guys have lunch in 12 minutes. You guys can talk about whatever you want to talk about. All right. Next up, what's 4 times 4? 16. And then 3 -3 is they have 9. And then you just rinse and repeat with the next row. So why don't you guys try the rest of this, and we'll check in about 1 minute. Let me freeze my screen. Why don't you guys try the other rows? I have faith you guys can do this. 2 plus 4, -4 plus 6.
I just don't know which one's a multiply.
8 plus 0. Yeah, give me a sec. Hold on.
Mr. E, okay, for like.
I'm sorry, say again, Jasmine?
So column 1, row 2.
Correct. So you do row 1, C1, row 2, C2. Then row 2, C1, row 2, C2. Then row 3, C1, row 3, C2. Yeah. All right. Here we go.
Okay, wait.
Wait,
For the-
it's
for
the
two.
Hold on, we'll get some more first. Yes, go ahead.
for the first one. Wait, I don't know.
So 4 3 is on the first row.
You multiply it already?
What was that?
For the first row and the answer, you have -8 plus 6. But wouldn't it be?
-8 plus -6.
Well-
4 3 -2 What?
Yeah.
Right.
Positive 8?
4 times -2 is -8. 3
Uh-huh.
times -2 is -6. -8 plus -6 is -14. Right?
Green is just.
Yeah.
I don't know.
Loading.
Good.
But I'm still confused about why it's -8. and -6, and now
Oh,
like
okay, guys. R1, let me write this down. I think I need. Okay, let's do R1, R2, R3. Here we go.
R1 times C1, then R1 times C2.
R1,
D2,
R2, R3,
R2, D2.
C1, C2. Okay, do you see why that's R1, C1? So I did 4 with -2 and 3 with -2.
wait, what?
4 with -2, which is -8.
Uh-huh.
What's 3 times -2?
6.
Exactly, that's where they come from.
Wait, what?
You just said it.
I know. Oh, it's because it has.
You just said it.
No, I'm still so lost.
Yeah.
I don't know. It's fine. You can keep going.
I'll keep going. Okay. R1 and C2 is over here. 4 times 4, 3 times -3. 16 plus -9. And you just keep going with the other rows.
2 plus
Mhm.
2 plus 4. Right there. Yep.
Yeah. The 2
Where
plus
did you
4.
get that from?
Okay, great question. Let me back up a little bit here. This is the beauty about Zoom. I can do this. All right. Oh, Ms. York sounds really upset about something. All right. Wow, she sounds really upset. Okay, here we go. So do you see what happened here, John? What's -1 times -2?
-1 times -2.
2.
2.
What's -2 times -2?
4.
That's why I have 2 times 4.
Oh, you multiply. Oh, I don't. I'm.
Were you
sorry.
adding?
No.
Okay.
I didn't realize that you were like already multiplying them together. and
Right.
adding them.
So you can multiply first and you add.
Yeah. I know,
Okay,
I just-
okay,
you
okay.
wrote it out.
Okay.
What's the?
So
She would like
R1, R2.
not really.
okay,
It-
bottom
it-
right, the 5 plus 0.
Okay, do you see how R1, C1, R1, C2?
Okay, for the 8 plus 0 in the bottom right corner. Where'd you get that from?
8 plus 0?
Yep.
That's R3, C2. What's R3, John? 2, 0. What's Oh, I know what you got. Okay, are you guys multiplying these numbers together?
Yeah.
No, don't do that. Okay, good. No, this is good. This is good. Now we're gonna clear up everything. Okay, good. No, you match up, John. 2, 0 matches with 4, -3. The 2 goes with 4, 0 goes with -3. 2 does not go with 0. That's what you're doing. It's 2 times 4 and 0 times -3.
0.
That's 8.
Oh.
Okay, guys, we see what's happening.
Oh.
I'm glad you guys are.
Oh. Okay. The math.
Shut up,
We're good.
Well, no, don't tell me shut up. It's good. No, because I don't want you guys just nodding and say, okay, you guys are copying stuff down mine. No, it's good. I want you guys to be open. It's all good stuff. 2 times 2 goes with 4, 0 goes with -3. 8 plus 0. Okay, it's 8. Let's try this another time. Actually, let's not do the second one. The second one's the same thing. Right, you multiply A with B and A with C separately. Let me get to the word problem. And if I have time, I can show you that one. But just so the second part of this problem is the same as the first part. Now, BA. Can BA be done? Because B is a 2 by 2. A is a what?
3 by 2.
3 by 2. Do they line up? Nope. So you say correct.
See, this is
And we call it dimension mismatch.
multiplying rows.
Not possible. Let me type it up.
First one,
That'll be better.
by row 2.
You can't do it. Mismatch.
Column 1 right there, and then row 1.
So
column
guys,
2.
the reason. All right. Guys, I don't want you like asking me on Wednesday, oh, I don't know the reason. The reason. It's a dimension mismatch. Okay, that's what you would say. The dimensions don't match. That's gonna be on a test to explain why it doesn't happen. It's a dimension mismatch. Right. Okay, that's why it would not be possible for multiplication. There's a dimension mismatch. Okay. For 12, I think we're good. Okay, let's do one word problem, wrap it up, and then we can break for lunch. And I'll see you guys Friday after that. So anyway. Okay, really quickly. Let's look at another word problem here. Okay,
Oh,
so now this is how, like on Amazon.com databases, for those who aren't here on Monday, when I introduced matrices. So like Amazon has so much data, right? So what's probably gonna do is probably gonna take, all the items you're buying, the price of the items, right? And it's gonna multiply together. It actually stores a lot of information this morning. So we're gonna create two matrices, an inventory matrix and a cost matrix. Okay, what's my inventory? What am I buying for this team here?
It's fixed, pucks and.
And how many different teams do I have?
Two.
I have two teams, women's team, men's team. Now the price,
Okay.
I do have a price. How much is hockey stick, guys? Yeah, it's fine. And how much is the uniform? Here's what we're gonna write.
Really? We're just doing something like that.
I know it's really easy. I know. I get it. It is easy to, I know, because it's a simple problem. So women's team, men's team, sticks, pucks, uniforms. All right. The cost matrix, sticks, pucks, uniforms. Take the information, guys, girls, we're almost done. Take the information, put it in the matrices. What am I gonna put in that left matrix?
the cost.
No, the inventory.
Oh,
Inventory and the right, the 3x1 is 62.
You can, yes, yeah, yes. Yeah, these numbers are pretty large. I wouldn't make you do these without a calculator. No, that's not, well, no, I'm not gonna make you do 14 times 6 in your head. No, that's crazy.
You have.
Well, I could do it. Okay, I can't do 18 times 35. Actually, no, I can't do it.
Okay.
It's 270.
W.
Okay, I'm showing off now. I am so sorry. Actually, no, I'm wrong. It's not 270.
L or.
It's 630.
No.
I know. You wouldn't know. Anyhow, you multiply this out, whatever it comes out to being. I'm not gonna. Yeah, I'm not gonna, but I just want to show you the process. So anyway, okay, we got through this. That's good. Homework is gonna be pages 5, 6, 7, I think. Yeah, homework's gonna be page 5, 6, 7. So you practice matrix multiplication. I have the answers all prepared. I'll put it in Schoology for you guys. Some practice logs, some old stuff. Solving a system with 3 equations, 3 variables, more rational function stuff. And by the way, these rational function problems came from my honors class about 12 years ago. So these are a little more advanced, but they're good problems to practice. No. Anyway, so that's the homework, page 4, 5, 6, 7, 6.4 homework. I'll post a Schoology so you guys know what to do. And yeah, we're done. We got about 2 more minutes left, so we'll stop for today.